There is something under all that ice. You can see it in the subtle curve of this NASA satellite image of Antarctica. It looks like the shape of a continent frozen solid, an inert lump of rock and dirt stuck at the bottom of the ocean for eons. But this is only half the picture. In reality, there is so much more to Antarctica than meets the eye. There are entire mountain ranges buried under miles of ice, lakes filled with water from before humans walked the earth, and yes, volcanoes whose peaks are just aching to break free. All of these features and more exist beneath the icy plains of Antarctica, hiding in plain sight but out of reach until now. This is what's really under the ice, the last great frontier on Earth. To understand what's under the ice, we first have to talk about what's on top of it. Antarctica's ice sheet comes in two flavors, coastal and interior. The coastal ice shelf is relatively thin, ranging from a few dozen meters to around 200 meters thick. These sections jut out from the landmass into the sea, looking like giant tongues of ice. They can be hundreds of kilometers long, but they're only around a kilometer thick. That's because as the ice gets thinner, it floats higher in the water. If the ice were any thicker, it would sink. Meanwhile, the interior ice cap is thick, very thick, up to 4,700 meters thick in some spots. That's nearly as tall as Mount Everest. This is made possible because the weight of the ice compresses the bedrock underneath it, allowing it to flex and sink with the ice above. As long as the ice maintains its current thickness, East Antarctica will stay high and dry. Well, dry except for all the water, obviously. So while there are rivers and lakes under Antarctica's ice cap, we don't expect to find anything too exciting under the floating shelves. That is, unless you count the wildlife. Because here and there, you'll find pockets of algae and phytoplankton growing in the sunlit waters below the ice shelves, taking advantage of the nutrients carried in by melting ice from the glaciers above. And that makes a nice habitat for small crustaceans called krill, which in turn provides food for seals, whales, and other creatures of the Southern Ocean. But if you want to find something really interesting, you need to head further inland to where the ice cap begins. Here, because the ice isn't floating, it's grounded on land, and that means there's no limit to how thick it can get. But it also means that whatever's underneath is out of luck. Just ask the animals that used to live here. More on that later. First, let's look at what you actually can find down here, starting with this, one of the most famous subglacial features on the continent, Lake Vostok. Scientists know of at least 400 subglacial lakes in Antarctica, but Lake Vostok is the largest of the bunch. Discovered in the 1990s, it's almost the size of Monaco and lies 3,700 meters below the ice. At first, scientists were shocked that such a large lake could exist under all that ice. After all, as its name suggests, this place is incredibly cold, typically around -3 degrees Celsius. But thanks to the pressure from all the ice above, the lake doesn't freeze. In fact, it's home to a whole ecosystem of microorganisms that seem to thrive in these conditions. What's more, the lake is full of ancient water, thanks to a quirk of physics known as the conservation of specific volume. Scientists think its waters have UNT mixed with the outside world, since it formed over 20 million years ago. That makes it one of the oldest bodies of water on Earth. In fact, it was here when our ape ancestors were swinging through the trees in Africa. Lake Vostok isn't the only thing hiding under the ice cap. There are also entire mountain ranges, like the Gambert Mountains. Now exposed in places, these ranges rise up as much as 3,000 meters from their base and may contain mineral deposits that could sustain mining operations. Well, maybe not right now, but in the future, Antarctica as potential as a mining site is why some people would like to see more of the continent exposed. Of course, others argue that disturbing such pristine wilderness should be off-limits. Speaking of things being off-limits, you might have noticed that I keep mentioning how various features are found under the ice, or that scientists think they exist under the ice. That's because, as incredible as modern technology is, we still haven't actually seen much of what's under the ice. We know that there are lakes and mountains and probably rivers too, because scientists have collected data from radar readings, gravity measurements, and even drilling expeditions. For example, the British and Argentines ran a joint project in the 1970s called, hold on a second, Project Big Ben. See, they lowered a drill bit almost 3 kilometers into the ice cap using a hot water drill. Then, after taking samples from the ice and analyzing seismic data, they concluded that the land underneath must be mountainous. But despite all of these efforts, what's under the ice remains largely unknown. It's like trying to read the bottom of a swimming pool without looking in. But there is hope. Modern technology is helping us take bigger and better peeks under the ice than ever before. Using multiple satellites, researchers are combining forces to produce these detailed topographic maps of the continent. Meanwhile, the International Thwaites Glacier Collaboration is studying the massive Thwaites Glacier, which holds enough water to raise global sea levels by 60 centimeters on its own. They're redoing this using a combination of old-school methods. like drilling ice cores and hot water drilling, and newfangled equipment like these cool little robots that scuttle around on the glacier collecting data. Because Thwaites is one of the fastest moving glaciers in Antarctica, it could play a major role in determining how fast the rest of the ice melts. Okay, but all that's still not good enough if you want to see what's under the ice. What we really need is X-ray vision. Luckily for us, physicists have just the thing. It's called a tomographic radar system. It's basically like a CT scan for continents. Researchers fly a plane equipped with special radars over the surface of the continent, and as the plane flies, those radars send pulses of energy into the ground. Some of the energy bounces back, revealing details about the structures inside the ice. This technique has already revealed some interesting things like the previously mentioned Gambert Mountains. But it's still hard to get a complete picture, because radar waves can only penetrate the ice to a certain depth. For the deepest lakes and mountain ranges, scientists have to do something else. A couple of times a year, teams arrive at the coast with a ship and a rocket launcher. Don't worry, they aren't planning on blowing anything up. That rocket launcher is for launching a rocket, and this rocket has a scoop on the end of it. See, rockets launch vertically, but this rocket is specifically designed to go off at an angle and then drop down into a hole drilled into the ice. Once it's in position, it releases a payload of radar equipment, which begins sending pulses of electromagnetic energy into the ground. From here, the rocket takes off again, returning to the ship where a team of scientists analyzes the data it just collected. In this way, scientists can map what's under the ice to incredible depths. For example, in 2020, scientists dropped a radar into a borehole in Antarctica and mapped a previously unknown mountain range, called the Southern Transantarctic Mountains. These mountains are about the same height as the Rockies and made of similar rock, but because they were covered by the ice, they had remained hidden until now. Even with all these tools, though, there's still a lot that scientists don't know about what's under the ice, especially when it comes to the most surprising subglacial feature of all, the active volcanoes. Yeah, you heard me right, volcanoes. There are at least 900 dormant volcanoes in Antarctica and at least 87 active ones. Take, for example, Big Ben, the world's southernmost active volcano. Discovered in 1949 and named after the nearby clock tower, Big Ben is 2,700 meters high. And while it hasn't erupted in the past 13,000 years, scientists are pretty sure it'll do so again soon. But the truth is, I know exactly how many volcanoes are in Antarctica or whether they pose a threat to the rest of the world. That's why one of the next steps in Antarctic research is learning more about these volcanoes. There are several ways that scientists plan to do this. One is by tracking small earthquakes known as microseisms that happen near volcanoes. Another is by detecting changes in the heat coming off the volcanoes. And yet another is by sticking instruments into holes drilled through the ice. With any luck, we'll learn more about what's brewing under the ice before too long. Of course, scientists aren't the only ones interested in Antarctica's secrets. Throughout history, people have dreamed of conquering this frozen wasteland, including Ernest Shackleton, who led expeditions at the beginning of the 20th century, and Adolf Hitler, who wanted to use Antarctica as a base for his Atlantic U-boat fleet during World War II. But one man's trash is another man's treasure, while Shackleton found nothing but adventure. Treasure hunters, scouring the continent after World War II, did uncover remnants of earlier explorers. There are the remains of Shackleton's ship, the Endurance, and the wreck of an Italian submarine that sank in 1943, as well as several whaling stations built in the early 1900s. While none of these sites are particularly beautiful, they are important pieces of history, and that's part of the reason scientists want to protect them. As Antarctica continues to melt, more of the artifacts resting under the ice will be exposed, creating an archaeological wonderland unlike any other on Earth. Hey, did you know that while much of Antarctica is covered in ice, there are actually some parts that are completely free of ice? It's true, and those ice-free areas are home to all sorts of interesting rocks, minerals, and fossils.